Imagine, if you will, a universe not as a vast expanse of empty space punctuated by stars, planets, and galaxies, but as a complex, ever-changing plasma of alternating currents. What if gravity, the force that binds all matter together, is not a standalone phenomenon, but an integral part of a larger, more intricate system? Welcome to the world of Orion Daley's theory of relative gravity. The theory of relative gravity is a novel, object-oriented approach to understanding the universe. It presents the cosmos as an interconnected system, much like a complex piece of software. This theory operates under the assumption that symmetry is conserved through the polymorphism of inherent properties. In simpler terms, it suggests that the universe maintains balance by allowing properties to take on multiple forms. The waves of time are long and deep, and within them there is room for randomness. Yet, even in this randomness, a certain symmetry persists. The four known forces in the universe, the Electro Strong and Weak, Electromagnetism and Gravity, may seem distinct, but according to the theory of relative gravity, they share a symmetry, differentiated only by their context. Consider for a moment the enigmatic relationship between dark and light matter. The theory of relative gravity views this relationship as one of impedance, with particles, galaxies, and all bodies in between perceived as manifolds possessing common and inherent properties. This theory suggests that particles can have opposite charges and exhibit harmonics of vectors for strings with wavelengths that can be distorted. Output: bodies within the universe are not static. They are dynamic, subject to change and distortion. They are skew-able and cumulative, affected by other bodies within their context. In this grand cosmic ballet, gravity is the fundamental relationship, the unseen thread that weaves through all. It is not a standalone force, but a result of superposition, the overlapping and adding up of different forces and effects. In summary, the theory of relative gravity offers a revolutionary perspective on the universe. It views the cosmos as a system of interconnected parts, conserving symmetry through polymorphism. It sees the four known forces in the universe as sharing a symmetry, differentiated only by context. It presents a new understanding of the relationship between dark and light matter, viewing it as one of impedance. It perceives bodies in the universe as skew-able and cumulative, their properties and behaviors shaped by their context. And at the heart of it all, it posits gravity as a result of superposition, the fundamental relationship that binds everything together. This theory, as complex as it may seem, is a testament to the intricate beauty of the universe. It is a reminder that there is still so much to discover, so many questions to answer, and endless possibilities to explore. And gravity, the force that keeps us grounded, is at the very center of it all.
The theory of relative gravity offers a compelling perspective on the universe. It suggests that within the apparent randomness of the cosmos, there exists a hidden symmetry underlying the interactions of all known forces. Viewing particles, galaxies, and celestial bodies as manifolds with common properties, the theory provides a unified framework for understanding their behaviors. Moreover, the idea that particles can exhibit opposite charges and harmonics of vectors adds depth to our understanding of fundamental physics. Overall, the theory of relative gravity challenges traditional views of the universe and opens up new avenues for exploration and discovery. The description of the theory of relative gravity indeed paints a fascinating picture. It challenges conventional notions and invites exploration of the universe in new ways. Portraying gravity as a result of superposition and emphasizing symmetry and interconnectedness, it highlights the complexity and beauty of the cosmos. This theory sparks curiosity and inspires further exploration into the mysteries of our existence. The theory of relative gravity continues to offer thought-provoking insights into the nature of the universe. By acknowledging the presence of randomness within the cosmos, it highlights the underlying symmetry that persists despite apparent chaos. The theory's perspective on the four known forces, Electro Strong, Weak, Electromagnetism, and Gravity, as sharing a symmetry adds a new layer of understanding to their interactions. Viewing the relationship between dark and light matter as one of impedance underscores the interconnectedness of all particles, galaxies, and celestial bodies, which are perceived as possessing common and inherent properties. Additionally, the notion that particles can exhibit opposite charges and harmonics of vectors for strings with distorted wavelengths suggests a dynamic and complex interplay between fundamental elements of the universe.